Okay, the next speaker is Karl Ahner. Is currently research associate at the Academy of Fine Arts in Dresden, School of Fine Art of Dresden, Academy of Fine Art, in the research project Greta, while studying MA Design, Products and Interaction at the Dresden University of Applied Sciences. Since 2016, Karl is also part of the team of robotic artists and musicians, Moritz Simon Geist, developing analog sound machines and media art installation. He's been an employee in the field of design and technical customer support in the 3D printing company Rapid Object GmbH in Leipzig, and served as a research assistant at the Fraunhofer IWS. As a background, he has studied material science at the Technical University of Dresden. Please welcome Karl Ahner, who is presenting materials applied to theater sculpting. That's it. Please welcome him.
Grazie. Grazie. Do you hear me good? Do you hear me well? Okay, perfetto. I know it's pretty late, so I try to keep this short, and of course I try to entertain you as much as possible about this more technical topic. So welcome to my presentation about 3D printing with natural materials, natural and also recyclable materials. So the question is, how can we generate large-scale structures for theater sculpting? First of all, before we jump into the topic, I'd like to tell you a little bit about myself and the project that I work in. I myself, you told, I'm a designer. I work also in music and installation. And since this year, I started working in this research project at the Fine Arts Academy in Dresden in the field of theater sculpture. And at the moment, we are 3 employees, a theater sculptor, an engineer, and me, a designer, which is a great combination to achieve good techniques and good materials. So, 3D printing. Do I do this? All right. So the presentation will not be solely about 3D printing. I will also discuss a couple of other approaches and other techniques, but this is probably the biggest and most important topic. And I mean, still, 3D printing is kind of a dream come true. Huh? You can tell a machine to produce anything you want. It's beautiful. You can make spare parts for machines or products. You can make prototypes and models. You can even print food or entire houses. The thing is, it is reality. We are printing food. We are printing houses. So, however, 3D printing in all its form also has its limitations, of course. So therefore, in the next half an hour, I'd like to take you through the basics of theater sculpture and plastics, so we get to know about the requirements and explore some possibilities for finding solutions using modern digital technologies and, of course, natural materials. So to better understand where we are here together, I'd like to ask you a few questions. Who has heard of 3D printing? Should be everyone, I guess. Okay. Who knows about additive manufacturing? Oh no, okay. It's less. So the thing why I mentioned this is that 3D printing and all its forms, there's very different ways of 3D printing, I consider a subset of additive manufacturing, because additive manufacturing also has other ways that are not 3D printing. This will become important later. So Lastly, I'd like to find out if any of you ever 3D printed or maybe asked a company to 3D print something for them or used 3D printed parts in their everyday life. Maybe you don't know, but how is it? You 3D printed? You too? Okay. Well, I hope in the next years more hands rise here. Okay, so why the reference to additive manufacturing? Well, we have to go this way. Right. So I've created a rough overview of the various ways people manufacture a wide range of objects using different methods and materials. So on the left side, we have subtractive ways or methods. So we remove material from, let's say, a big block of something. We remove until we're left with the result, what we want. And on the right side, of course, we have the additive ways or methods. So we put together stuff until we have the result. And it can be, I mean, on the top we have the manual ways. So you see, you can by hand remove stuff, or you can put together, let's say, clay or something you find in the earth in your garden, and in the end you have a nice pizza oven in your garden just by putting stuff together. And on the bottom we have the machinery, so a milling machine that removes material until you're left with the part, or a 3D printer that like additive manufactures stuff. A lot of things you use in your daily life are manufactured using other, like injection molding, for example. I leave this out here a bit, but technically it's like in this corner. Okay, so stage design or theater design often dazzles with intricate theater sculptures. They are large, they are colorful, they are movable, and indispensable for many productions. So unfortunately, these sculptures and their production are often associated with significant material usage, and in some cases, even non-recyclable waste. So often you have to make the sculpture, and if you don't need it anymore, what do? You can just throw it like in the worst bin. Maybe it's burned or something. Yeah. So, quoting my professor Ulrich Eisner, who initiated the whole project, he says, "The Fine Arts Academy of Dresden, as one of the oldest European art academies, has always been a place where art technologies and craftsmanship have continually evolved." So this points to the significant future topic or theme, creating artistically high quality, stable, lightweight, durable, resource efficient, and sustainable theater sculptures. So that's a lot of requirements, a lot of things to ask for. So how should that be possible? When we briefly examine the diverse methods that are used in theater sculpture, we find a lot of ways. There is like carving from the solid block, there is welding, wire wrapping, modeling, molding, casting, laminating, coloring, painting. So we realize probably there is not this one-fits-it-all solution. We're not looking for that. So that's why we are following different approaches, of course. Okay. Oh, yeah, you see here. Here we have a little insight into another project of a student from the academy. It's a huge elephant, and it's movable. You can see it. It can be moved by 2 people. So this is again this very important point. It must be lightweight, very lightweight. And the cool thing is you can see that, for example, here we didn't use like a huge block of styrofoam and carved everything out of it, but we already use some natural materials, and that is great. That's a good way. So, how do we start? If we want to use these modern digital technologies to create objects, we need a digital model. That's the first thing. Currently, we cannot simply tell the 3D printer what to print. I guess with the AI revolution, this is also just a matter of time, but okay, we leave it there. The process involves digitizing a physical object, and you do that by using a 3D scanner, of course. So there are very expensive systems that you can use for that. Of course, they are more precise, but you can also do that with your smartphone. There are even free apps that you can download. Probably 99% of your phones can do that. And you can just move around an object, and the computer will create a digital geometry based on the imaginary. So I really suggest trying this, it's fun. And here you can see my colleague, Leopold Dietrich. It's a bit a problem with the video, but you get the idea. Can we? Yeah. So here you can see what the green is, what the scanner sees, and the computer just puts it together until you have like a complete model of what you're scanning. It's quite easy, to be honest. Okay. Here's a comparison with the app on my smartphone. So just you see how easy this is, or the thing is, you will also see some mistakes that the app makes. It's not quite as precise, but it still works. You can work with that. So, yeah. Okay. So next, we prepare the object for the rematerialization. So the method we use depends on the geometry and how we plan to reproduce it. I mentioned earlier, it's not just about 3D printing, we also have other ways, so there we would go another way here, but let's stay with 3D printing. And what you can see here is a cross-section of a torso. And to achieve lightweight structures, that's what we want, we don't print a solid object. We print it hollow. We just print like the skin, of course. And to make it a bit more stable, we put in there these curvy lines. So this is kind of a support structure that gives some stiffness to the whole object. The problem is right now, like actually when you use like a usual 3D printer, there's a software called Slicer, and it will generate the code for the printer automatically. And also it will generate support structures automatically. We cannot do this right now because we use some special mode in our printer. We have a modified printer, and we print in a mode called vase mode. So it's like one continuous line. We start at some point and we just go round and round and round. And also the curved lines in the inside have to be part of this continuous line. That makes it quite hard. It takes some time to make this manually. But of course, this is also part of our project to look for a good way to make this automatic. So here you can see our printer. It's called a Big Rep 1. It has this huge space, like 1 by 1 by 1 meter. And we modified it because when they gave it to us, it was meant for polymers. And now we want to print other materials. So, and this is how it looks. So, before we go back into the technical stuff, I'd like to, or let's say other. So what we use as a nozzle to print this material is a 4mm diameter nozzle. We tried a lot of different nozzles, round ones, square ones, bigger ones, smaller ones, but we ended up with the 4mm nozzle, and this gives us a good thickness for the skin of the object. So the actual question is, what are we printing? What is the material? So to unveil this mystery, I'd like you to, I invite you a little tour through our laboratory and our material collection. So we've been experimenting in the last 2 years with lots of different materials. And the thing is, we don't use one material, we use material systems, like compounds, 3 or 4 most of the time. And one main thing is the binder. We also call it the matrix. And the other thing is the filler. The filler makes the material lightweight, it gives volume, and the binder is just there to glue them together, these particles. So printability is the first major requirement for our material. The material needs to flow from the reservoir through the nozzle onto the object layer by layer. That's the thing. So material can't be too liquid or too solid. It needs to be viscous enough to be extruded from the nozzle and then harden or become load-bearing relatively quickly. That's the thing. When you go round by round, it will collapse if it doesn't harden. So in conventional 3D printing with plastics or polymers, it's relatively simple. You heat the plastic up and put it layer on layer on top of each other, and the thin line cools very quickly. So it becomes hard, and the next time you go there, it's already hard. So in this picture here, however, you won't see polymers, but lots of tests using agar-agar, for example, clay foam. We foam up a lot of stuff, and also we tried gelatin. So the list is longer. We've been trying alginate, saccharide, like different kinds of sugars, lignin, chitosan, casein, which is a protein, which is very good glue, bone glue, whatever. So lots of things as the binders. And as fillers, you might, maybe you think of, okay, what is there in a workshop? There's a lot of sawdust, for example, wooden sawdust. Why can we not just use that? Or a cellulose fiber, which is also used in lots of methods in the Fine Arts Academy. So both are lightweight, relatively easily available, and they're nature-based. That's good. Or you can think about millet husks, puffed corn, or just crushed plant residues. So, well, currently we work with cork powder. The thing is, cork powder is exceptionally lightweight, and this is the most important point, it's hydrophobic, so it repels water. Because when you work with water-based binders, then the filler will absorb some of the water, and that leads to a couple of problems. First, it gets heavier. Second, when it dries, it will shrink. And lastly, or like the worst case would be that you have mold, which is really undesirable. So this is why we use cork. It doesn't absorb the water. That's perfect. So let's do a little comparison between gelatin and agar-agar. Both can be printed very effectively. Agar-agar works even better because it's slightly less viscous, and so it makes it easier to extrude from the nozzle. However, agar has the drawback of being less stable, and it takes longer to harden. This brings a lot of limitations to us. For example, printing speed. The thing is that agar hardens when drying, and gelatin hardens when it cools down, because it's kind of a thermoplastic. So it's worth mentioning that we mix water as a base with glycerin, and the thing is that this reduces the shrinkage while drying, because the glycerin stays in the object. And also, I really invite you to get hands on the stuff that I brought. Also, the glycerin makes the whole thing a little bit rubbery and not that stiff, not that brittle. That's good. So now you might be wondering if this is actually practical, if we can use it in real world application. So let me put it this way. There's a German philosopher, Richard David Precht. I don't want to discuss the other theories of him, but he once mentioned that it will soon be possible to produce steaks using 3D printing. And of course, this is to overcome mass animal farming. And at this point, I'm really proud to announce that we already produced not just steaks, but we produced entire pig halves. Sounds a bit strange. Why is that? So, we were asked by a theater close to Dresden if we can produce 2 huge pig halves for a new piece that they are premiering. So, we went to a slaughterhouse with our 3D scanner and had 2 freshly slaughtered pig halves, scanned them, so we had the digital model. And in the next step, of course, we had to prepare them for the 3D printing, and we did that in segments. So we didn't print the whole thing. They are like almost 2 meters high, but we print them in 6 or 7 segments. And then these segments just could be stacked together, glued, of course, with gelatin, filled and sanded, and that's basically it. I mean, it took us 2 weeks, because the printing is quite slow still, and you have to wait until the parts dried, but it's okay. And so yeah, this is again my colleague Leopold with the final results on stage at the theater. Of course, gelatin cork basic structures, they were painted with biodegradable colors, and then they were loosely put into this foil to like just prevent some influence from outside. But yeah, I think it looks quite good. Okay, so next question, next very significant question is this actually recyclable? So let me give you an example. If you have like a 3D print and it just collapses, let it be because we put a wrong geometry or we have like the wrong material mix. Then what do? We just let it dry, we grind it down to small particles, and then we can add it to a new mixture the next time. We just put in some water in, we heat it up to 70 degrees Celsius, and it becomes like glue again. It's good. It works pretty easy. Yeah, it's reusable a couple of times. We've not tried out yet how many times we can do this, but by now it's it works quite well. So this is the process. Of course, it's a time warp, but you can see. And it's like the upper upper part of the pig. It's like the leg. And yeah, we print up to 70 centimeters height by now. We hope to, of course, bring it up to 1 meter or something, but 70 centimeters already is quite good. So yeah, that took about 3 hours. Okay, so next very important question. You might rightfully wonder if gelatin and cork are really more sustainable than styrofoam. It's a good question, because I mean, gelatin comes from mass animal farming, cork comes from cork production. Right now it's relatively easy to get these products, and it's also, they are quite cheap, cheaper than other materials we use. So right now these are byproducts by big production, but in future, of course, we want to overcome this too. So again, that's why I'm thinking of sawdust, for example. It's just available in your workshop. Or you take plant residues from local agriculture, would be perfect. And binders, for example, a binder made from lupine seeds, for example. Lupine is also well cultivable plant, and so yeah, there's still a lot of research to be done. And that's why I want to talk about some other methods too. Fortunately, this 3D printing process that we work on is not the only method that can be used. We found out that not far from Dresden, in Freiberg, it's a small town, they have also a very good university, and they work on powder bed fusion. So here the process works that you put layer by layer the fine powder of the filler, and then you go like with an inkjet printer, you go over it and print the glue or the adhesive just where you want it to be. The cool thing about this is that you don't need these kind of support structures to support the whole, if you have strange geometry, because everything lies in this powder bed. It's great. And the cool thing is, the powder that has not been used, just put it back to the reservoir and can use it the next time. So it's a very great field. I mean, unfortunately, we don't have the possibility to do this, but I'm happy that they are working on that. So, hence, I'd like to briefly discuss two other approaches we're exploring. And I mentioned earlier that additive manufacturing is not just about 3D printing. So this seems easy, seems very simple, but I think sometimes the simple methods are the best. So just with when you have the digital object in your computer and you slice it, you make a lot of layers. You can define how thick the layers should be, and then you could just use the laser cutter and cut out from cardboard. And I mean, cardboard is a quite good recyclable material. And then you stack it together and you have super stable, super lightweight structures. And you just can work on them too. And in the end, if you use paper, for example, to make the surface, you can put it just into the trash, into the bin. It's fine. It's cool. So now it gets a bit strange, but also very interesting. We have been working together with the Technical University in Dresden because they, or the Department of Bioengineering, they work on mycelium, on growing fungi. And of course they do a lot of research in chemical ways to use fungi and mycelium. But also they try to grow structures, defined structures. By now it takes a lot of time, a lot of energy, it's very complicated, and we also cannot use this, for example, very well for theater sculptures, but I think there's a great potential in this field, so we should keep that in mind. And I mean, last but not least, actually, I mean, when we think of styrofoam as a petrochemical, why is there not like a just natural way to produce this kind of foam? So mycelium might be one way, but there's also other ways. So I guess you have heard of peanut flips, or sometimes you maybe receive these small foam items in a package you ordered. These flips are typically made from polymers, but some companies offer them made from cornstarch. And I think there's also a company called Fisher-Price, and they produce it for children to play with. So you just lick it, stick it together, and there's your magic castle. That's cool. You can actually even eat it. So what did we do? We built this extruder. It's a crazy machine. It's super loud, needs lots of energy right now. And what you can see here is colored polenta. We put polenta inside, and in there's a screw, and the screw generates really, really high pressure. And through the high pressure, it puts the polenta through the nozzle, and it gets super hot, and this heat makes the water evaporate, and so it foams up the polenta when it comes out of the nozzle, and then it cools, and it stays like that. And here's a couple of the results we have lately been doing. I also brought something here. It's super stable, super lightweight, and you can easily work with it with a knife or something. The only problem is, of course, it dissolves in water, but okay. And this is how it looks. So it's quite funny, actually. So yeah, the biggest problem with this approach we are facing is that we don't know how to put it in a defined volume yet. Maybe I find a company that just produces large blocks of it. I haven't found it yet, but if you know something, just don't hesitate to tell me. Okay, so I'm right about to get to the end, and I want to reference to a presentation from yesterday. Klaus Schöning, he was presenting some of his work, and when we met, it's been a couple of months, not too long, we were realizing that our approaches or methods, we could bring them together. So what Klaus did on the two left pictures is visualizing data. And so what we want to do now is visualize data about waste production in this way, and we print this, and then we put it into the compost. So that gives, first, it makes a great piece of art, and second, we gain knowledge about how good is our material compostable. So it comes together perfectly, I think. So that's it, and thank you very much for your attention.
Any questions?
So nice talk, really nice talk. Just a couple of curiosity. The sculpture that you reproduced, which material was used to realize? The last slide you showed before for representation. It seems like a furniture or something like this. Obviously, is it not? But just to say, just to know which material was used for last. The last one that you used to represent last slide. This one. Yeah?
So the one on the very left is just plywood.
Mm-hmm.
So this is, like wood
Yeah.
composite material. The one in the middle is MDF. But
MDF.
this one is actually, so I already tried to grow stuff on it. So it was MDF, but I kept it, I incubated it for about 1 month in a dry space. So there a lot of stuff was growing on it.
Okay.
So that's why it kind of
Yeah.
already. But I didn't have the technology to really produce a big material that is completely compostable fast. And so I was very happy to find this project, and now I can finally, after 5 years, realize the sculpture and really compost it like more efficiently. Because on the MDF there's only stuff growing on it and not really eating it, right? Because the MDF sucks water and the moisture enables micro.
And then you have effect of shrinking or swelling of material. Yeah.
Shrinking, growing, it's all kind of, it all got crooked. When it was finished, it was really perfect to 1 millimeter about, and now after this thing, it totally got kind of deformed.
Yeah. So the second question is more general. It's a kind of philosophical question. It's about the actual growing of multimedia support for representing 3D structure. So do you think that this growing field could go against your work? So because you are realizing real sculpture, and actually in the theater or even in event happening that you participate in person, the object are realizing using visual effect. So the feeling is different, because if you realize a real sculpture is different if you represent in the 3D mode. So you think that this new trend is going in the right way compared to the real fabrication of sculpture?
It's a very interesting, also very complex question, because what we do is not just doing this research in this project. We also want to apply this to the universe, like to the university, of course. We want students to use these processes. And the thing is, what we realized is, and it's also beautiful, that most of the students who go to theater sculpting, they follow this very romantic approach of working with the hands and the material, of course. And so it's not so easy to bring this digital technology there. A lot of people are refusing to do it, which is fine. If you want to work with your hands, do it. It's great. But I think, I mean, the world is changing, and universities are a great place to bring together a lot of stuff. We don't want to say, okay, this method, this material is wrong, get rid of it. No, that's not our approach. We want to widen the tool case, and we want to invite people to think about, okay, maybe there's another way I could work. And I mean, there are fields, for example, if it, in terms of when you think of like really small figures, 3D printing is very common actually. But if it's in like for the big, large-scale sculptures, it's not there. But so we just can try to invite people to maybe try it out once, or not even 3D printing, but use digital technologies to make a 3D model with the scanner or laser cut things. And I think it is good to try out to widen this tool case so people have more knowledge, have more possibilities also. I mean, of course, when you look at the field of 3D printing, then it's mostly about polymers. The development is huge, many countries and many fields. But I hope that it also goes for natural materials, and I also hope that it goes into the fields of not just science, but also the arts. So I think I'm quite optimistic. But, yeah.
Just a curiosity. So there's a strange, I feel a certain tension between the idea of theater sculpting and the actual stage, which is less and less deals with sculpting, no? Because nowadays stages are more and more digital as a space, and the majority of time you don't have object on stage. So strange enough, there is a very cutting edge technology applied to something that is disappearing from the stage. So I feel a certain tension that I just wanted to share with you.
I see that tension too, but the reality is when I go to the Fine Arts Academy and I look into the workshops or I look into the fundus, then there is 99% of the sculptures is made from styrofoam. And they produce, year by year, they produce these huge amounts of styrofoam waste that is hardly recyclable. And so I think it's pretty relevant to work on that, even if we have development in stage design in general, bringing more digital things in there, like projection or whatever, it's true. But I mean, students really learn for a couple of years to work with styrofoam. Lots of other materials and methods too, but when I go to the university, then I see this. So I think it's quite relevant. We'll see. Okay. Please come here and get hands on this material, yes.
I already did.
Well, thank you, everybody. And I think that the key word here is experimentation. Experimentation is the key word in the art, not just in the 16th century, but also in the contemporary art. And so you are experimenting and finding new way of expression, and also using the hands, because you did use the hand in the material you are mixing. And so, well, congratulations, and thank you everybody for this very interesting day. You remain.